After that intro, it's time for us to get into looking at essentially finding the area under a curve, or what's sometimes called the distance. And we're going to look at table questions. So imagine you get a table where this is the time and this is the velocity in red. And if you imagine plotting it, it would look something like this. Now, if you've done physics before, do you know that the area under a velocity time is the distance? So that's why they called this area under a curve and distance, and that was its name. So we are going to find this fella, and we only have these values to work with. So if you can imagine what the strips might look like, they would be these guys here, right? And can you see that there's going to be 5 strips? And I'm going to find L5, right, using the left-hand endpoints, and R5, using the right-hand endpoints. And from these table values here, this guy is going to be called T0, T1, T2, T3, T4, and finally T5. So if you're not sure from a table whether it's going to be an L5 or an L6 or whatever, if you just start at the first one and call it X0 or T0, whatever the last one is, in this case T5, means that you're going to do a 5-strip deal, right? It's going to have 5 strips in it. So you're going to do an L and an R. Now, one of these is going to be the big guy, and that's going to go under here, and that's the answer that you would write down in WebAssign. And the other one's going to be the small guy, right? And it's going to go here. And you can wait until you find the answer, but I should be able to tell right now. Would you agree that this function is decreasing? It's going downhill. So let's look at R5, just randomly. The first strip, you use the right-hand side. So that's going to be your rectangle. The second one, right-hand side. Third one, right-hand side. Fourth one, right-hand side. Last one, right-hand side. Do you see that these red rectangles that are going to be used are lower down? They're underneath the curve. So wouldn't that make R5 an underestimate, a small value? Right, now, I've written down the formula very algebraically, but basically what you do is you take the width, which is delta t, and you find the value of the function at these given points, add them up, multiply by delta t, and that will eventually give you the area estimate. Now, you could have written that down if you wanted to, but nobody does because it's too much work. Couldn't you have written it down as a whole load of separate little rectangles like that, right? Isn't this the same as that calculation? Because it all involved the same delta t, right? It's just how high you make the rectangle. And the height of the rectangle are these values. So in this question here, oh, from my table, what is the value of delta t? What's the value of delta t?
Hello? It would be b minus a divided by the number of strips, which is
right?
5.
Yeah, so 10 minus 0 divided by 5, which is 2. Or 0 to 2, 2 to 4, 4 to 6. You could guess it's 2, couldn't you? You'd be right. So 2 goes there. Right. The value of the function here is 8, then it's 7, then it's 5, then it's 5, and the last one we use is 3. So that's going to be 1528. And so in this case, I'm going to get 56. And if I do the second one, it's going to be 2. But notice the formula is just a little bit different. You don't use these 4, or these 5, I should say. Those are the 5 that we used here to get L5. We're going to use almost the same lot, but you notice there's a little difference. So I'm going to just use the last 5, and that's 7, add 5, add 5, add 3, add 1. That's 10, that's 21. 2 lots of 21 is 42. So in WebAssign, the largest estimate is 56 and the smallest is 42. So this moving object that is given by little snapshots of what its velocity is at a given time generates this. We are saying that this moving object traveled somewhere between, in total, 42 to 56 meters. Right? The underestimate is that it's 42 or better, and the overestimate is it's 56 or less. So somewhere in those two extremes. And we can say that for sure because this is a decreasing function. Are we comfortable with the process here? Because once I've shown you one, do you know every table's the same as that question? Really, isn't it? It's just to change the numbers on you. Maybe it's 4 strips, maybe it's 6 as well, but that's about all they can do. So if you keep this one as a kind of template for how you do the table questions, I think it'll help you get through some of these early questions relatively quickly. So I'm going to pause right now and nip over and show you what the homework looks like so I can show you that in operation. Right. Okay. I think I might be able to make this a little bit bigger because some of you might be working on quite small screens. Does that help? For some of you at least. Right, now, can you see that's very similar to the one I've just did? There's a table, there's the velocities. Right? Set it up with calculations L5 and R5 like I just did. And I have no idea what the answer is, but 42 goes here and 52 goes there, right? Now, in this question here, although it is a table vertically, will you think of this as T0, T1, T2, 3, 4, T5, T6, and T7? That doesn't really matter for the question, so it doesn't matter, right? T7, right? Right, T0, 1, 2, 3, 4, 5, 6, 7. Since this is T7, and we want to do an estimate of it, they ask us for the upper approximation. Now, I could find L7 and R7, and the bigger of those two is the answer they're looking for, right? I could just do it that way. Looking at this table, do you think it's going to be T7 or letters of the alphabet, right 7 or left 7? Let's call them that. Right 7 or left 7, which one do you think is going to give me the overestimate?
Right 7.
Correct. Do you want to explain why, or is it just a gut feeling?
Because your left is going to include a 0 and your right is going to include a large number.
That's a pretty good way of telling it, right? Did you all catch that? If you didn't catch that, couldn't you just get left 7 and right 7 and the biggest answer is the one you put in? I guess that would take you a bit longer, but you would be able to do it. Now, what's different about question 3 is that you don't have your table that you really want. And we're being asked to get left 7 and right 7 and a new guy, which I'm going to show you in a moment. So it's left 6 and right 6, I should say. So in this picture, although you can't see me writing it, I will be writing it down as I talk through this. We are going to do 6 strips. Now, do you notice that it goes from 0 to 48? From x equals 0 to x equals 48. So delta x is b take away a divided by n. 48 take away 0 divided by 6. And that ends up being 8. So we are going to go 0, 8, 16, 24, 32, 40, and 48. So again, you can't see me doing this, but I'm writing down what I'm talking about. It's going to be 0, 8, 16, 24, 32, 40, and 48. And maybe I should just jump back and forward for a few seconds. From that diagram, that graph, I figured out that the width of the rectangles, the delta x, is going to be 8. And that allowed me to create these guys, right? Now, the y values, I'm going to get them by reading off the best I can, so it's going to be a little bit of a guesstimate, right? What the given height is at 0, 1, 2, 3, 4. So you are going to help me out here because I'm not the best guy at estimating answers of graphs because my eyesight is shot. Okay. At 0, it's that guy there. Now, if you look carefully at the scale here, isn't one box worth 4? So would you agree that when x is 0, the y value is 36? Are you all comfortable with agreeing with that? Right, now it gets tricky. Here is the position of 8, and it's there. Now, I don't think you could expect a human being to estimate that to 5 decimal places. Would you agree the best we could probably do is a whole number? And I'm going to go 35, and some of you might think 34, and I'm not saying I'm right and you're wrong. Would you say it's 35 or 34? I'll take whoever shouts first as my answer.
35.
Okay, 35 gets the job. Now, if we go to 16 and we get that, would you agree it's just a little bit above the 32? So to speed things up, can you just trust me and call it 33? You might disagree by 1, but I'll live with that. And the next answer goes here. And that guy there is 28, and this fella's just a little bit above it. Would you want 29 or 30 for that one? It's just a little bit above 28.
I would do 29.
Okay, works for me. That way, if this is wrong, I can blame some of you for it. Oh, 32 is nice. Would you agree it matches that guy there? What number is the y value at that guy there?
24.
Okay. 4 gets to 20. The next box is another 4. 24. We're almost done with this darn thing. 40 would be here. Oh, that's perfect. Is it not 16? And lastly, 48 is that guy, and I make that 4. So I'm now going to return to our whiteboard where all those numbers that I was talking about have been written down. Are you comfortable about how the diagram became a table? Are you comfortable about how I decided who the x's to use were and what the y corresponding values are? Now, oops. I'm only going to do L6. You could figure out R6 yourself, right? This guy is called X0. This guy here is X1. This guy is X2, 3, 4, 5. Perfect match. You see how that's 6 and this is 6. If you do the left-hand 6, the formula is delta x, the value of the function at x0, at 1, at 2, at 3, at 4, and finish at 5. I don't expect you to do that as your homework. I'm kind of doing this as a template thing, right? Just so you can see where the heck these numbers are coming from. Our delta x is 8. And when you do the left, don't you use the left guys, right? All those guys. And if I was doing the right, wouldn't it basically just be these guys? Right, so not a lot of difference between the two. Right, what kind of numbers are we talking about? A 36, a 35, a 3, a 29, a 24, and a 16. Well, this is dangerous. 11, 14, 23, 33, 6, 9, 12, 13, 14, 15, 16, 17. And 17 times that guy, what have we got? 8 times 173. I'm looking at a 1384. Are you comfortable about how we found L6? Diagram became table, table became calculation. If I was going to do R6, wouldn't I basically be using those numbers? And I have no idea what the answer. Just so I can write something down, can we pretend that it's 1200? I know it's not, it's just a random guess, right? But you would get the answer. Now, there's a new guy in town. Midpoint 6. So what is midpoint 6 look like? Well, here is his general formula. It's delta x, f of x bar 1, f of x bar 2, 3, 4, 5, finally 6. And who are these x bars? Well, you need a totally new table. Oh, let's do it visually. Can you imagine here is 0 and here is 8, right? 0 to 8. That guy's called x0, that guy's called x1. Midpoint 6. What do you think the x coordinate of the first midpoint is going to be?
4.
And that guy is x bar 1. Which means I have to go back to that blinking table, and I now have to create a table with 4. Actually, we need to do all of them. So if the first midpoint is 4, what will the second midpoint be, the one that goes here? 8 on one side, 16 on the other. What's the middle?
12.
12. Have you noticed that there's a connection here that allows me to do all the others without actually calculating them? Once you know the first midpoint, can't you figure out all the other midpoints? What is the connection between this one and all the other ones that come after it?
Add 8.
Which is exactly what delta x is. So, okay, figure out what the first midpoint is by doing, halfway between 0 and 8. But once you've got that one, just add 8 to everybody and you're good. Now, that means I have to go and I have to get the y value. I'm going to cheat here, and you're just going to trust me, which is dangerous. Whoops, because I'm probably going to get some of them wrong, but forget it. I'm going to call this guy 35, because I can. The next one I'm going to call 34. Next guy is going to be called, what's that, 29. Next one, 28. It's going to be 27. One of the shorty guys here. What's 36 look like? 30. This one, oh, that one I can use. That one's 20. And the last one is 16. Now, don't be surprised if I screwed up here, because I've really just rushed through them. What I hope you're getting is how I got the numbers or where they came from. Right, there they are. Now, if you've got this guy set up, isn't it basically delta x, which is still 8, but won't the numbers be this guy, this guy, this guy, this guy, this guy, and this guy? And I'm just going to go dot, 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 right? And you get whatever you get, right? 1300, right? Just for argument's sake. So we have got 3 different ways of estimating what the area under a curve using only these points would be. We really did L6, it was that number, right? We could have done R6, we'll pretend it's this number, and we kind of have done M6, which is this number. So far, so good. Now, why do we need a third one? Well, do you know that we want to get a kind of range of choices so that we can kind of figure out what would be our best guesstimate? Can you imagine that L10 was 200 and that right 10 was 240 and M10 just happened to be 210? When you put those 3 together, aren't you likely to say, okay, I don't know what the right area is, but it's somewhere between 200 and 240, and my best guesstimate was 210. So you've got a kind of range of values where you believe the answer would live, and M10 tends to be, out of the 3 choices, M10, the midpoint, tends to be more accurate than L or R. Now, there are always exceptions, you know, weird curves sometimes work in unusual ways. But the general truism is that the midpoint is going to get you the most accurate answer. And then these 2 are equally good stroke equally bad, and they're next. So if you only had time to do one estimate, choose the midpoint one if you can. In general, it will give you a better, i.e. more accurate answer. Are we good with even though I dotted a whole load of the board and adding up stuff? You got the gist of how you would do it. This guy will be online as well, so you'll be able to see it later this evening, and you can check it out if you find I went through some of it too quickly. Okay, I'm now going to return and look at what the homework looks like. Question 4 is back to, here's a table, find the lower and upper. We've kind of covered that. Question 5 is another graph one. And you're going to do M6.
Hey, on question 5,
Yeah.
can you just explain how to find delta x on this one?
Sure. Now,
Yeah,
in this question,
seconds,
right. So in question 5, we started at 0 and we finish at 30. And the 6 tells me it's going to be 6 strips. So B, take away A over N. Start, take away, finish, divided by how many strips? So 30 take away 0 divided by 6 gets you 5. So we are talking delta x is 5, okay? So I'm going to kind of draw a very bad version of that picture so I can draw on it for you. And it looks something like this, which you'll see in a few moments. Let me jump back to our original screen. Here we go. Right, so that's roughly what the picture looks like, right? What I'm saying is that delta x is b take away a over n. The start is called a, the finish is called that, so that's where the 30 take away 0. We were being asked to find midpoint 6, so that makes 6 strips. That's where my delta x of 5 came from. Now it gets a little bit tricky here. I'm going to have to create a table. That's kind of how you do these guys. And we're going to 1, 2, 3, 4, 5, 6, right, all together. Now, there's 0, there's 5, there's 10, here's 15, here's 20, here's 25, here's 30. 1, 2, 3, 4, 5, 6. You see the 6 strips. If I was going to do the left end points, wouldn't I be using these x's in my table? If I was doing the right one, wouldn't I be using these x's in my table? I'm not going to use either of those. 0 to 1 isn't the midpoint at 2.5. Isn't it halfway between the 0 and the 5, the midpoint? Now, the midpoint for the second strip is going to be here. What's that? About 7.5? Since I know that this is 5, can't I just keep adding 5s to these to get all the other midpoints? Now, if you want to visualize why is a midpoint a better answer than a left or a right, let's look at this first rectangle. If I used the right-hand side, wouldn't I get a very big rectangle? Overestimate. If I used the right-hand side, wouldn't I get 0 rectangle? But if you use the midpoint, do you see you get a rectangle that is, some of it is not being used up, but some of it is shy? Do you see that they kind of balance each other out? Choose this one here, right? That's where the midpoint would be, right here. Can you imagine that that rectangle here has a little bit shy and a little bit too much, but don't they very often at least partially cancel each other out? So the net effect is that that rectangle is pretty accurate. Have I convinced you that midpoints do a better estimate than a left or a right could in general? Right, is there any more about this question? So what you're going to do then is you're going to go back to that chart and you are going to have to guesstimate, and it really is guesstimate, what the height of the function is at these numbers. And if I return to that question, there is going to be a lot of wiggle room here. If you look at 5 and 0, 2.5 is about here. If I go up, it's about there, and I'm reading off there. Would you agree that there's probably going to be a give or take 1 every single time? You think it's 23, somebody else thinks it's 22. If you think it's 22, you write 22 down. If you think it's 23, you write 23. Which means that the answer that you're going to get is bound to be inaccurate, or there's going to be a lot of variation in the answers. So we just hope that WebAssign is generous about reading off answers. Right. I don't think anybody could look at question 5 and tell me what the height of the function is at 2.5, right? What that guy there is, to more than to the nearest whole number, and even that's pushing it. Are we good? There's another one. So by reading values from the graph, 5 rectangles, find a lower estimate. Okay, if you are going to use this picture and you're going to do 5 rectangles and you're going to do the answer from 0 to 10, 2, 4, 6, 8, 10. So that should finish there. Okay. Won't you go up in twos? So your first strip is 0 to 2, 2 to 4, 4 to 6, 6 to 8, and last 8 to 10. Since you are looking for a lower estimate, are you going to find a right 5 or a left 5? I mean, just look at the first strip from 0 to 2. If I did this side as my height, the right-hand side, aren't I going to get a whole load of rectangles that are shorter than the area? That's what you need to do. And then one of these pictures represents what we just said. And would you all agree it's that picture? So you just pick a dot on it. If you pick the right-hand side to get the height, you see that's where the first rectangle is. There's the second. Now, in this one, you want an upper estimate. And if it's an upper estimate, won't you use this fella here? So basically, they're just asking you for right and left 5, but they're just making a meal of it. Oh, that's a fun one. Good luck. Here's another one. 20 square root of x. Okay, that one I think I'll do. Because that one has some information that the others didn't have. So f of x is 20 square root of x. We're going to do it from x equals 0 to x equals 4. And we're going to find R4. So everything I need to know I've written down. Right. So A, B, 4 strips. So first thing I'm going to do is find delta x. And it's B take away A over n. 4 take away 0 over 4. You can't get much easier than a delta x of 1. Step 2, create your table. Well, I'm going to start at 0 and go up in 1s, so that's not much of a table. And that's my x's. The height of the function is given by this guy, so that's nothing, that's 20. That's 20 square root of 2, 20 square root of 3, and finally 20 square root of 4, which is 2, so that's 40. Now I should be able to find R4. Delta x, the value of the function at x1, 2, 3, 4. And just to remind you how we label the x values, we're using the right-hand 4. So that's going to be delta x, add all those guys together. And can I just say ... here? Isn't that grab your calculator, start hitting buttons time, round off your answer to 2 decimal places. So you'll go 20 plus 20 root 2 plus 20 root 3 plus 40. Technically times 1. You don't need to do times 1. And round off your answer to, I take it back to 4 decimal places, because that's what WebAssign asked. Now, isn't it much more accurate if they tell me this guy? If I just use the graph, wouldn't I be guesstimating what the height is at various points? But in this case, can't I get really good answers? And they talk about under and over estimates, but we've done lots of those, so I'm not going to spend any time doing that. Let me pause for a minute. Yeah. Are we okay with how to find left, right, and midpoint if you're given a graph or a table, depending on the question? You feel comfortable with it? It takes more time than it does brain power, but we feel comfortable we can do those. So I'm leaving that then. Hopefully I've covered enough for you to be able to do those questions. And we're going to take a totally new piece of information. We're going to look at, for the last 7 minutes, something called sigma notation. Suppose I wanted to describe adding up all those numbers, 1, 2, 3 squared, all the way to 100 squares. I could write it like this, ... plus 100 squares. And that would represent a very big calculation. You agree? But it's a very clunky way of writing down a lot of things being added. So sigma notation is a way that mathematics is a technique that we've used to simplify the process of adding lots of things together. And it has this shape to it. It uses a big funny letter that looks like that. And if you know anything about Greek, this fella here is the Greek letter sigma. It's a capital sigma. If you've ever heard of sigma, remember that little guy that looked like that from statistics? He's also called sigma. He's capital sigma, he's lowercase sigma, right? So if you're wondering how come it's called sigma, it's like capital A and little a, right? They don't look like each other, but they're both A's, right? So Greek letter, sigma. You then put in, you can really put any letter you like in, but I'm going to do k equals 1 to 100 of k squared. Now let's see how that represents this. Well, k equals 1, you plug in 1, you get 1 squared. Sigma means add up, starting at 1 and finishing at 100, using this as your formula. Can you see that that is representing this? Can you see how 1 squared plus 2 squared plus the next k is 3 squared and so on? For instance, if I gave you that in sigma notation and I said, what would that look like if you wrote it down in full? Well, wouldn't you plug 1 in and you'd get 3, then you plug k2, then k is 3, then k is 4, 5, 6, 7, 8, 9, 10. Isn't that much better than that? So it's just a little skill building exercise on how to take a whole load of things being added up and converting them into sigma notation. Or you're going to be given sigma notation and asked to figure out what it means, and then add the whole thing up in your calculator, and I'm making this up, write down what the answer is, right? Not a lot to do with what we've been doing, but eventually it will integrate with it. So, suppose I'm being asked to take that summation and rewrite it using sigma notation. And I'm going to do sigma k equals. Right. What number should go at the bottom here? This is a nice easy one to start with.
1.
Great. In this particular example, what should we finish with? K equals
15.
15. Now, the only thing that you need to fit in here is what expression using K would generate these calculations?
K cubed.
And we've just answered the homework question. This is messy. This is concise. Mathematicians hate writing down anything we can possibly avoid. Have you ever wondered why we don't write 1x? Because can't we just write x and everybody knows it means 1x? Don't we write x cubed? Because we need to. But don't we not write x to the 1 because we don't need to? Can you see how mathematicians are nitpicky about minimizing everything? Don't write anything unless you absolutely have to. And if you've got a big horrible thing like that, why don't we write it like that? It's so much cleaner, right? And it means the same thing. And that's the key. It means the same thing. One of the questions that you're going to get in your homework looks more like this guy here. Now, you are going to have to use your calculator, right? There's no way to avoid that, right? This fellow over here. But let's figure out what it is. K equals 1. Well, 3, nothing, 0.1, so it's basically what, 3.1? Then you plug in K equals 2, and what do you get? 3.2. Then you plug in 3. And then finally you plug in 4. Do you see that that basically just means this? And once you know that, don't you then go to your calculator and you do your 3.1 plus 3.2 plus 3.3 plus 3.4 and you get your answer. Oh, what a really nice answer, 13. Now, what they're likely to do to you, because WebAssign does not like you, is that they'll get you to do that. Now, it's not harder, it's just boring and longer. Agreed? You just have to add 10 things, right? So 3.5, add 3.6, add 3.7. So when you're hitting your buttons on your calculator, will you please be careful? It's so easy to miss one of them, right? And your answer doesn't work. And you only get 3 shots, so it's better if you get it right the first time than having to redo the whole darn thing a second time because you skipped a number or you typed in 3.1. No, you typed in 1.3 when you meant to type in 3.1. You know, you did something like that. Okay, we're getting very close to the end of today. So can I ask you all to say hi so that you can get your attendance for today? And what else to tell you? We have got the officer set up now. So if you go into your Canvas site, you'll get the link. It's 10 o'clock each day. So I'll have an open Zoom meeting, an open officer, and you will drop in if you need to, right? If you have any questions, maybe one of your homework questions is just driving you crazy. I'll tell you right now, some of them will, and it's not your fault. Do you know the ones where you're reading off the height of the function? And you could swear blind it's 3.6, but the textbook or the software decides it's 3.7. Can you imagine it's going to tell you you're wrong when really you're right? I wish the software was a little bit more resilient. It's very good at algebra. It's a little bit clunky when it's estimating, guesstimating stuff, right? It's just less generous. So if you really, really get stuck on a question, and I can tell you what the right answer is, and if you're so darn close it makes no difference, I'll just go in and give you the points for that homework question.